Hi, I'm Sahaja Priya, and my teammate is Satya Sai Priya. Our team name number is 23. Now we are going to give presentation on Spike System Smart Scheduling of Observation. Coming to introduction, this paper talks about Spike System, which was made by the Space Telescope Science Institute for NASA's Hubble Space Telescope. Because there is a lot of demands for astronomical observatories, they appreciate how well they are used. There is a computer called Spike that was made of Hubble Space Telescope, but it has since been used to solve other problems in both astronomical and non-astronomical fields. Aside from the basic idea, Spike add new techniques to both how hard restrictions and soft preferences are qualified, and how scheduling search algorithm based on multi-star stochastic repair or use it to find the best time for tasks. Next slide. Coming to the schedule of HST, the HST unique combination of wavelength coverage and angular resolution has changed astronomy research since it was first used in April 1990, when it was the first put into service. Despite the main mirrors manufacturing flaw, the HST is still doing research that has led a lot of exciting findings. In late 1993, the space shuttle will come and fix HST. It will replace the main camera with a new one. These changes will improve the telescope optical quality. Next slide. So, in this picture, the main constraint of HST scheduling is how much time it takes to observe. There must also not be too much data processed by the communication and ground systems. The onboard tape recorder storage and the onboard command computer storage, which must also be not existed. So, despite the fact that the HST is mostly planned and there are some problems with the schedule, most welcome interruptions are rare. Most important astronomical events that need to be taken care of right away. Schedules get thrown off when there are problems with spacecraft communication problems and changes in what people looking at. Because so many constraints work together over such a wide range of time scales, it's impossible to pick a single scheduling factor that is the most important in this case. There are a lot of constraints that are cyclical with different periods and stages at different times. A lot of time that HST runs on the pre-planned schedule, but things can go wrong for a variety of reasons, such as bad weather or other problems. So the schedule isn't always set in stone. Next slide. Representation and combination of constraints and preferences. There are two types of constraints. Those are feasibility constraints and preference constraints. Coming to feasibility constraints, when it comes to setting conditions or times for things, we call them tough or difficult constraints. These terms refer to the things that can be broken, but they don't refer to the things that would normally be broken. These words are used when talking about the human target system HST. They refer to the things that must be done in order to keep certain level of precision. If the target is 50 kilometers away from the sun, then this is how it is from the sun. As a result, the spacecraft should not be rolled at more than 30 degrees to the side of from its normal direction. Preference constraints are used to set up high satisfactory judgments on scheduling scenarios that were once wanted but no longer needed. Most of the decisions can be made mostly on objective or subjective factors. Next slide. Coming to the consistency methods, uh, there are many types of consistencies. The first one is node consistency. In our formulation, we explicitly say that we don't take domain values into account. This is because in most cases, these values are set by unrestricted rules. Arc consistency. To meet the constraints of binary variables, y takes values outside from the ranges of the variables. When a network must have a certain distance between each end, this is the most common way to do it. Additional constraints or constraints that can be inferred from the statements that say they are there. The fact that the one constraints come before another means the other constraints come before the first one. Complex constraints like having a group ready in 24 hours can be more difficult to figure out. Next slide. Computational aspects. Putting suitability features on virtual hardware means that non-stop suitabilities have to be broken down into a time, a fee, or both. For two important reasons, we did not spike breakup time in any important way. It adds a synthetic time granularity to the problem, and many critical constants lead to suitability features that have a long period of steady value and cannot be efficiently represented by having a lot of same value for a lot of different points. This is a waste of time. Next, HST scheduling as a constant satisfaction problem. So, constant pleasure problems are made up of a group variables that can have different values and a set of constants that limit the values. Each variable can be based on a given values of other variables. The goal is to keep the all variables at the same value while not breaking any rules. It is easier to turn a scheduling problem into a CSP when we think of each activity as being scheduled with the variable. We divide the time range for each activity into periods based on the area of the variable. The Spike CSP toolkit is made up of number of object classes and their associated methods. The most important of these are the abstract classes for CSP, which is set of variables, constants, and other things needed to model a constant satisfaction problem. Which is and the variables, which is a set of variables, their assigned values, conflicts, preferences, and so on. Next. Coming to the Spike CSP toolkit, some of the most important things about the toolkit are consistent assignments logged and did not use variables. Uh, Next, weight that are used to limit the amount of space. Constraints, catching is the process of removing and restoring domain values and capacity constants, and a history of assignments and screenshots. Next slide. The final one is time stamping. The most important decision is whether or not to leave out the whole interval. If the whole time period isn't included, there is a chance that viable solutions will be missed. If the interval isn't excluded, the scheduler might find what looks like a good configuration. But when the timing is looked at more closely, it turns out that isn't possible. We went with the option B for HST scheduling in general. We first started, but we switched it to an option for specific constants as we learned how to do it. To choose the right solution, you need to think about both the constants and how hard it is deal to with the consequences. Now the continuation will be done by Sai Priya.
Thank you, Sahaja. Hello, everyone. My name is Priya. Next, I'll continue next slides. The topic is Spike and HST science scheduling. This is a science scheduling. The telescope low Earth obtained every environment caused the majority of its operational constraints, and potential targets are only visible for a portion of each orbit, and before availability of Earth in their limitations. They are also constraints imposed by thermal and power conservation, which is the limit the satellites allowed by altitude at the different times of the year. And astronomy specifiers specifications constraints when they are defined exposure to achieve their scientific goals, and minimum exposure time, temporal relationship among the exposures, and before and after grouped with the sometime are commonly for this science edge schedulings. And coming to the process flow for the HST scheduling, the process, a recent change to the HST ground systems now allow to simultaneous the operations of two instruments, which is expected to significantly increase the amount of usual data collected by the telescope. And also because of telescope and ground system designs, nearly all HST activities must be planned in advance. The detailed scheduling outline which command will be exposed by the onboard computers, and as well as when communication contact for uplinking commands and downlinking data will be available. Observe real-time interaction is essentially limited to small point correction to accurately place target into the proper instrument aperture. And this long-term scheduling allocate the observation to the week-long segments over the scheduling period of the time. And the second short scheduling, which is allocated to observing the week-long time segment over the scheduling period of the year. And next, the proposal preparations. The propositional preparations give a brief overview of how exposure evaluation tool will be used in HST science operations in the section. Long-term planning beings with the systems pool of the approval proposals, and these ideas have also been checked for the syntax and semantic issues. And this proposal can be proposed to PEEP transformations, which is defined to SPSS scheduling data structures, but it is not required for long-term planning. A planner can also entire pool of accepted proposals or as a subset of them, like for example, only high priority and time sensitive proposals. Coming to the relevant proposal data is extended to the PEEP transformations to a spike work strips, and following that, a planner creates a segmentation line timeline and dividing the plan's time to interval to the segments. And coming to the transformation, transformation is operational and plays a critical role in the HST ground systems. It has originally built using the OPS 5 expert systems language forwarding chaining, and but it is also since been re-implemented using proposal knowledge base, and this re-implementation will necessarily by the increasing the amount of OPS 5 code required to exposure to more complex situations required expert level intervention to the transformation knowledge base, and this information the difficult in the prevention of individual rules and interaction exhibited in the problem exercises and small but powerful common lip extensions was created to the support the transformation knowledge base based on XSL has a simple syntax for definition assignment and reference to the object attributes and irritations and etc. For the over object of the performing keyword lookup for also support by XSL, and this transformation need to reintroduce effort in order to maintain and improve the day by day. And coming to the long-term scheduling, in long-term scheduling, HST science operations rely heavily multi-layer planning. This basic observation cycle is 1 year long, and observation from previous and subsequent cycles to must be taken into account, and also priority observations from the previous cycle may not be exceeded. Various reasons will be created over in the cycle. Although the majority of the proposals will be completed in a single cycle, some will be for multiple layer observation program, which will be having to impact on the future observative cycles. And furthermore, during the first few years of HST operations, these instrumental team science verification called SV proposals are mixed with the science communication general observation GO proposals. Long-term planning will be necessary to ensure that short-term scheduling are in the line with the long-term plan. And coming to the short-term scheduling, this short-term scheduling involves in the science operations of a HST are heavily reliant to the multi-layer planning. The basic observation of cycle in this observation of the previous and subsequent cycles must be considered. And these observations from the previous cycle may not be carried into this cycle of the various reasons. Although the majority of the proposals will be completed in a single cycle, some of them will be multi-layer observation program, and that will be effective the future observation cycle. And also first few years of HST operations institutes theme science verifications proposals mixed into a general observations. Those are mixed into a long-term plan, and which is necessary to the long-term plannings. And coming to the implementation, Spike was first implemented in the early of 1987 with the hardware and the software environment based on Texas Instrumental Exposures. The Spike graphical user interface was written in Telecrop KE Common Windows, but the rest of the systems was written earlier in Common Leaps and the Flavor Objective Systems. In this, STSLs had a complement of 8 TL explorers and micro explorers and spike operations developments, and also testing at the time of the HST launch. There has been a lot of progress in the hardware and the software since beginning of the spike in development. To keep up with these changes, a significant amount of effort has gone into a modification of the system. We are transferring from the Explorer to Sun fraction of the late 1991. Coming to the operational experience, This has not only reduced HST scientific utility, but also it also threw the scheduling process into a disarray. In this year before launch, observing the plan had to be reversed, and resulting shortage of ready to schedule observing the program, and the result of efficiency with the schedule could be generated a true long-term schedule. Instead, Spike is used to regular basis to identify the observations that should be scheduled in 2 months in advance of these operational experiences. And coming to the application of Spike to other astronomical scheduling problems, one of the most permanent application is the astronomy has been high profile observation scheduling as an artificial intelligence technology has progressed from the research lab to more widespread use. In this Spike scheduling system was developed by the Space Telescope Science Institute for long Hubble Space Telescope scheduling called HST. Spike has been used to STLCs on daily basis since well before the HST was launched in April 1990. Other mission has been added into the system. One of them is EUV is currently operational, and another AstroD will launches in the February 1993. And the Spike is being to consider for the users by the other potential space to astronomy of missions. And also Spike has proven to an adaptable and efficiency scheduling tool. And coming to this AstroD long-term scheduling generated with the Spike, this diagram is considered like long-term planning can now begin with the goal of committing each cluster to the segment in the with what will mostly likely a year ago or multiple year plan. This plan has been number of options to choose from. The clusters can be committed manually through the user interface or else automatically through scheduling software. The timeline display give you a visual representation of the commitment to the cluster and how it became unscheduled as a result of the other factors. This schedule is iterated until a satisfactory result is obtained. In this, planner can create a new segmentation during commitment process to the experimental with the different scheduling options. This system current state can be saved file for the future planning sessions. And coming to the conclusion, finally, the Spike exposure evaluation tool are usually for long-term HST observation planning, and the representation and the propagation of constraints clusters exposure to reduce the number of entity schedules, and also decreasing of all time reduce of the number of place examined, and a user interface that displays the relevant information in a concise manner are all important aspects in reducing this is to be traceable problem. Yeah, finally, thank you for this opportunity. Thank you.
Thank you.